to Ollie about this. We started working with Apache Storm to process our data. So I thought I'd do a little brief intro on Storm, how it works, how to get you going, and just do a very basic thing. And then we've got a use case of why we're using Storm, what the problem we're trying to solve, how we did it wrong, and how it should now actually be. So yeah, here's my name, email, whatever. So you can get in touch with me if you've got any questions after this. And I'm a software developer in the search team and content discovery. So I guess the first question is, what is Apache Storm? This is taken straight from the Apache Storm website. As you can see, Apache Storm is a free and open source distributed real-time computation system. Storm makes it easy to reliably process unbounded streams of data doing for real-time processing what Hadoop did for batch processing. Storm is simple, can be used with any programming language, and is a lot of fun to use. Now, I've highlighted here distributed and reliably, because these are the two key things that we chose Storm for over other solutions that we were looking at after we had did everything wrong. So one thing that Storm does guarantee to a certain extent is that every single message that it'll ever process will be processed completely throughout the pipeline to the very end. What they mean by that is actually it can fail, so during the pipeline any process can return a failed message, but that is fine because that is it completing it. Also, of course, it can go all the way through and be happy and successful, in which case it's an acknowledgement back, and that's also great. So what makes up Apache Storm? So here are the key components. You've got 3 infrastructure components and 3 logical components. The 3 infrastructure components are Nimbus, Zookeeper, and Supervisor. I'm sure a lot of people probably have used Zookeeper. They've used Solar Cloud or a lot of other Apache technologies that have recently been used. It's quite popular. We've used it for a couple of years now with Solar Cloud, but it's the first time that we're using it with Storm. Nimbus is something specific to Storm, so I would assume that not too many people have used it. And Supervisor is, again, a specific thing to Storm. It's not the Supervisor that you can use as part of your box to make sure your process is up and running. That's something different, but is also something that you should be using. The 3 logical components are spouts, bolts, and streams. So in your pipeline, your spout is your starting point, your bolts are what are processing it, and your streams are what's connecting them together. So here's the Nimbus. What does it do? So as you can see, it ensures the correct number of bolts are up and running. The main thing about this for Nimbus is that for them to have everything working in a clustered form, they allow any bolt to be connected to any other bolt of the same instance or spout. It doesn't matter which node it's on, it doesn't care. And all Nimbus does is make sure that you've got the right number up that you have specified. So for example, you may only have 1 spout because you're reading from 1 queue, so you don't want to have 2. But you want to make sure that spout is always up no matter what. So should that spout die, Nimbus will make sure that there is another one up and running ready for it. So what if it goes down? Well, nothing stops running, which is great. But however, as you can see, that it can't maintain the correct number of bolts or spouts whilst it is down. As soon as it's back up, it's fine. It doesn't have any state or anything, so it can just come back up and carry on doing what it's doing before. However, we're currently only using 0.10.0 of Storm, so we've not officially started using 1.0. We're starting work on that, but it is quite a big change from what it used to be. So we've had a lot of issues, and we've not got very far. But as you can see there, it's only clustered since Apache Storm 1.0.0. So before then, if you've used it, so it's only became version 1, I think, on Monday. So if you were using it before then, you'd have had a single point of failure, which is Nimbus. So I know a lot of people, so some people from the search team, they used to work in Yahoo, and they've used this before, and they had to try and deal with only having 1 Nimbus up. So Zookeeper, this is something we've got a bit more knowledge on. But what it does is this is what contains the state of everything. So nothing in our in any of the other components within Storm actually contain any state. That's how they keep the statelessness, by using Zookeeper. So this is something that we have used in search, as I mentioned before, for our solar cloud. So again, what if it goes down? Well, nothing really stops running. It's still okay, but it's still not working as it's meant to be. As you can see there, spouts and bolts only know about the spouts and bolts that everybody knows about. So if I've got a spout and bolt on box A, and I've got spout and bolt on box B, it could both be the same, and they can talk to each other, that's fine. And Zookeeper tells the ones in A that there are also spouts and bolts in B. Now if Zookeeper goes down, well, they still know about each other, so they can still contact. But if I bring up box C, they don't know about it until Zookeeper comes back up and then go, oh, actually, you can reroute your data through to box C. So known issues. We've actually had a lot of issues with Zookeeper with Solar Cloud. Not specific to Solar Cloud, they've all been specific to Zookeeper. Some issues were things like it wouldn't start up when brought down a data center. So we use Hemel and Slough as our two data centers. We brought down Hemel as part of an overnight test to see what happened when we brought it back up. Zookeeper refused to start back up. Also, it brought itself down one box at a time. It decided that it didn't want to exist anymore, and it just disappeared. We found this out to be purely around timeouts that we'd configured. So out of the box, Zookeeper doesn't. It worked fine locally. It'll work fine for a while, but there will be cases where you need to tweak it specifically to your environment, and we found that out the hard way. You're probably thinking, well, that's kind of obvious, isn't it? Really? I mean, you're going to have different network latencies, whatever Apache's trying to give you. But yeah, time constraints and then just lack of knowledge, and these things happen. But it is highly available. Once you've got it working, it is rock solid. Since we've got it working, it hasn't gone down at all. So that's pretty great. And finally, you've got your supervisor. So this ensures that the topology is running. So the idea being that your supervisor is what's actually processing what's containing your topology with your spouts and your bolts in, and this is where you deploy it. So when you do your deployment, you'll have your Nimbus deployed onto your clustered set of boxes. You'll have Zookeeper, again, deployed on another set of clustered boxes, and you would have your supervisors deployed wherever the boxes you want. You can mix match. You can have them all on the same boxes if you want. You can have all your Nimbuses and your Zookeepers and whatever on boxes. That's not a problem. So what if this goes down? Well, your supervisor's holding your topology, so you're not going to do much if your topology's gone. So your topology is your spouts and bolts. So without those, you're doing nothing. So, and again, known issues. We've only recently managed to start deploying it due to other business constraints. So things seem to be working fine, but we've not really used it long enough to really say, here are the issues that we had, like we can with Zookeeper. So going down to your topology, you've got your spout, which is the start of the topology. So this ensures that, this is the thing that ensures that every message sent is fully processed. So as long as you're using a reliable spout, which is what's recommended by Storm, it will resend any messages along the topology when it fails. So these things can be either a timeout has occurred. So if you've got a spout, bolt A and bolt B, bolt A is taking a long time, the spout will resend the message. And if the bolt returns a failed message, so again, bolt A can go, okay, well I tried to do something, I might be storing to a database, I failed to store to a database, I need to reprocess, so I'm going to send a failure back, and then it will reprocess the whole message again from the spout. If the spout dies, the documentation isn't entirely clear on what happened here. So again, we've tried out some things and things seem to be working, but we're not sure whether the case is technically true. But we believe that if a spout dies, the message needs to be replayed from the source. So whilst bolt A can fail and the spout will replay it, if the spout dies for whatever reason, it will have to start up, reconnect to wherever its source is, and then replay that message from where it thinks it left off. So it is down to the source, whether it's a queue or whatever, to send the correct message. So then you've got the bolt. The bolt performs the logic. So whatever it is, it's just a generic process that happens. So once you've done your logic, whether it's to store into Mongo, whether it's to do whatever calculations you've got to do, It then sends the message along the topology when it's done. So it will emit what we call a tuple, which is just a message. What it then does, it will send an acknowledgement back to the spout to say, I have done what I'm going to do. If it's failed, for whatever reason, it will send a failure message. So the spout will then get this failure message, and you can deal with it appropriately. So, for example, you try and store the database is down. You might go, well, it's down, so I'll put it into another queue, and then it will get reprocessed later. Or it may be that you try transforming it from object A to object B. It doesn't work, so therefore I'll try and process it later, or I'll send it to monitoring, and it can throw an alert. But it could be something that is simply, it's tried to process it, it's ran out of memory, in which case the spout will try again and it will go to a different bolt. So the stream, fairly simple. All it does is literally connects your spouts and bolts together. So as an example here, you've got a spout which goes along stream 1 to bolt 1. Bolt 1 sends the message along stream 2 to bolt 2. Later on, I do have some example of the configs of how you can set it up. I might explain it a bit better. So how the message is sent. So currently in 0.10.0 it uses a mixture between netty and disruptor. So it will use netty for transferring to different nodes. So you can have the same topology on 2 different boxes, in which case it will send the messages across via netty between the 2 of them. If it's staying on the same box, so you may have 2 topologies, they may be exactly the same, but it's decided that the best route is to keep it on the same box and pass it through to the same bolts. What it then uses is LMAX disruptor. Now, if you're really old and using 0.8 or 0.9, it will actually only ever use LMAX disruptor. If you're using 1.0, from what I've read, it's actually using netty now for everything. So as I mentioned before, your tuples are sent and they're emitted along the streams between the spouts and the bolts. So tuples by default can only deal with common types. As you can see there, they're just standard object types they can deal with in primitives. You can create your own custom serializers if you want to have your own object. That's pretty simple. So there are 3 main things with streams, and that's your groupings. So here's the 3 main ones. There are many more than that, but most of them are pretty much variants of these. So shuffle is something that we use all the time, and what shuffle does is it takes a message, a tuple, and it will just pass it on to any bolt that can process it, that is the next bolt. So if I have a store to database bolt, I could have 3 instances of it, of which case with a shuffle it will just pass to any of them. It doesn't care which one. You can group by field, so that could be, well, I have 3 objects. I have airings, I have programs, I have seasons. Now for airings, I want them always to go to 1 bolt. For seasons, I always want to go to another. For programs, I want to go to the 3rd one. And for partial key, it's a extension of field where it's multiple things. So maybe, well, I want airings that are for the UK to go to bolt 1. I want airings that go to Ireland to go to bolt 2, that kind of thing. The reason why you'd want to do that is that you may want to enforce a single, kind of like a queuing type system between your bolts. So it may be that you only want to store them 1 at a time of a certain type, because they have to be processed in a certain order. So that's what that gives you. But for us in search, we don't care. We just want to store the data, so we just use shuffle. Right. So I've kind of gone through what Storm is, but the useful thing that we really cared about as well, from a once it's up and running point of view, is monitoring. Our monitoring is, to put it bluntly, rubbish. It's just shocking. But what Storm does give you is a very nice UI and provides a lot of details about your topology, what's running, what's going through it, how heavily is it being used, which bolts are the bottlenecks, which streams are being overused, that kind of thing. I've got some diagrams after this to show you, and it is very, very useful, and it's very good to look at. Just an example here. So Apache Storm doesn't solve all problems, of course, because if Storm isn't working, how do you know? Because Storm UI won't show you anything. So what we're using is CheckMK. Of course, you can use whatever other tools you've got, but that's just an example. So for us, CheckMK is just a nice, simple framework for custom infrastructure checks to be displayed. So it's just a simple way that we can have Ruby scripts that run and just send messages to a board. So here's some information on what the Storm UI provides. So these are the things that are really useful from our point of view. Is how long has it been running and what's the load on the Spout/bolt. So this is what we care about at the moment, because we don't know what data is coming through right now. We don't know whether we're scaling out our bolts properly. We just have no idea what's going on. We kind of know we're following specs, but we don't know what the real world's like. So the Storm UI is giving us some very useful information on this when we eventually get it running, which is not that frequently at the moment, unfortunately. So for the streams, it tells you which bolt the data is going to, which is, of course, always great to know the data is actually flowing through, which is already something that we spotted, and how long it's taken to go through the stream. So it provides a percentage of the amount of data that's going through via these streams, and it gives you a time in milliseconds of what the average processing time is. So here's some examples that I got today from our just deployed topology. As you can see, it's got things like your Nimbus configuration, the host that we've deployed our supervisors on, and then here's this looks a bit of a mess. Had to quickly take it, unfortunately. You can drag this all around to make it a little bit nicer, but you can see how you've got these blue spouts that start off your pipelines. You can see the streams and how some are thicker than others. The thicker they are, the more data is going through them. And you can see the light green bolts have nothing going on. And then you can see it goes all the way to the red one there, the airing persistence bolt, which is just storing the airing for us in Mongo, is quite heavily hit. So this is something that we'd probably want to scale out and look at come next week. And then here's some more information about the spouts and bolts, so specifically just the one topologies. This is our transformation topology, which I'll give a bit more details later on. But you can see how along here you've got all the different bolts, how many of them you've got, how many tasks they're running, and then the amount of tuples they've emitted, and so forth. So what about testing? So to give a little bit of, I really love Storm's testing. As you can see here, integration tests can be run on a bolt. So all you have to do is start up your bolt, start up a kind of a mock spout, connect your spout to your bolt, pass data through, and you're done. And you can see what appears on the other end. Gives you a lovely little framework. Also, end-to-end tests are fantastic from my point of view. Everything's in memory, and you can access each tuple sent during the test. So if I have a spout and two bolts, I can see what the spouts produced, I can see what the bolt A's produced, I can see what bolt B's produced. And then, of course, I can test what's been stored in the database and so forth. Currently, what we've had to do with our current setup is whenever we want to do end-to-end tests, we have to have a whole environment up. And it is absolutely horrible, because not only do you have to deploy about 1 million different things, it's an environment you're taking up, it's the amount of time that goes through, making sure all the data is going through. This can tell you where the data is. You can find out where the data is at any given point, rather than what we're doing at the moment, which is put data in one end, keep hitting the other end until we know we've got data. So that's kind of a nice quick overview of Storm. But of course, how do we configure our topologies? So there's two ways of doing it. There's the Java API, which uses a topology builder to create a topology. So all you do is create your topology, which is an object. You then add in your spout, you then add in your bolts, and you then create streams, connect them together, and then you just put them into if you're running locally, you put them into a local cluster, and then that will start. Then you can then start that local cluster, and that's kind of how the end-to-end tests work. If you're running externally, then you have to use the Storm submitter. So you still create your topology, use a topology builder, you still create your bolts and your spouts and your streams, put them all together, stick them in the topology, and then you do the Storm submitter, which will then submit it to your Nimbus, wherever you've got that running. Now there's a new, slightly, in my opinion, better way of configuring it, which is this thing called Flux, and this is what we use. And what you do is use YAML files to specify your bolts and your spouts and your streams. There's no code, and it doesn't matter whether you're running it locally or you're trying to run it remotely. It doesn't matter because Flux deals with all of that for you. And here's an example of, this is just a brief part of our YAML file. This is the bottom 3 bolts and the top 4 streams. As you can see, you just specify an ID for it, the class name that's going to be that it uses, how many you want, which is parallelism, and then your properties. This is the sort of data that is that you can put into your Java objects. So, for example, our bulk Java objects expect a payload input field. This is the sort of field that we're expecting data to come in on. The action input field, what action we want to perform on, because this is for Solar wrapper, which can deal with updates and deletes to Solar. An output field, the field that we're expecting to be able to output tuples onto, and then our service provider, which is how we can. It's a nice way for us to put all of our components together, all of our Spring components together. And you can see here with your streams, all you do is specify the ID, which is your name, and then the 2 bolts that are from. A nice convention is just to use the name, which is ID, then your arrow, and then the ID of where you're going to. And then you specify your grouping and the stream ID. So again, here, if you're using field, you specify type as field, your stream ID would be whatever stream ID it is, and then you specify the field that you want to group by. So we've configured it, fine, we've done all the code, everything's nice. How do we start it? So what you need is a conf storm YAML, and inside of this is just some very simple properties, which are the correct Zookeeper server locations, and this is purely so Zookeeper can know which ones it needs to keep in touch with, make sure everything's up and running, but also for your topologies, your bolts, your spouts, and your Nimbus to be able to store its state on the Zookeeper. You need to specify a local directory to store config and jars. So you might think, well, if it's supposed to be stateless, why do you need a local directory? Well, your supervisor does need the topology config, so it does need to go to Nimbus and pull down that config. It does need to be able to run. So when you deploy your topology, you're actually pushing up your bundled jar with everything in it, and you're pushing it to Nimbus, and then your supervisor's going, right, give me this topology, I need this topology, and now it's got it, and then it can run it. So again, you also need, of course, the correct Nimbus server locations, because your topology is not going to be any good if it can't even contact Nimbus to pull down this config and the jars. And you need to have available ports for each worker in the supervisor. So a supervisor can have multiple workers. And inside your worker is your topology, and you can have multiple of them, but they need to be able to connect to each other. Because they need to connect to each other, they need open ports. So all you have to do is specify at least 1 port per worker. You can have more ports than workers. It's not a problem. When you fire up more workers, it will just start using the next available port. So, and then once you've deployed your code to the correct nodes, whether using Docker or just deploying it however you want, all you then need to do is then run via the Storm script. So if you were to download, you've got to download Storm, unzip it, and inside of that is a Storm script, and that just allows you to do certain commands like pushing a topology to Nimbus, starting a topology, and that kind of thing. So for example, for running it locally, you would unzip Storm, and you could just do storm jar mytopology.jar, then flux, and then localconfig.yaml. That will then start locally your topology based on, say, a local YAML like that. So that's kind of supervisor. So start again. That's Storm in a nutshell. It's kind of where we got to. So far, it's been really good, but we've been hindered by a lot of business requirements, having to rewrite logic rather than having time to really get to grips with Storm. So, the search predicament. So, this was our original problem about 2 years ago that we were given. So, we had to consume from some queues, assemble the data into a single airing, rank the airings, create suggestions from those airings, rank the suggestions, ingest the airings into Solar, ingest the suggestions into Solar, and it has to be cross data center /active-active. So those seem fairly simple, fairly trivial. However, this is what our thing ended up looking like. And note, this is not everything, by the way. This is just the main things to process data. Not exactly fantastic, to say the least. So quick overview. We've got on the left-hand side is your source of data. You've then got, here is the way to just how we consume the data, store it into Mongo, transform it to what we want. Again, store it in its transform state in Mongo, grab what you require, assemble it all together, pull it out, put it on where it needs to be. So, for example, a person is part of a credit, so you assemble person for credit. Credit is part of a series, put it onto the series. Series is part of an airing, put it on the airing. And then on the far side, you can see the red squares. There are APIs, which are then feeding from Solar, which is feeding from the ingesters. Those ingesters are reading from the assembled airing Mongo collection, which is there in the middle, and pushes that data into the airing collection in Solar. And some of these also make it into their own collection because we have certain APIs that require it. On the top right, that is purely just around trying to deal with suggestions, which is always falling over, and we're always having problems with it, and we're always having to give it a kick, probably I'd say every week, every couple of weeks. So it's a bit of a drain on us. And the other week, I had to give it a kick, and when I was on support, for about 3 or 4 times over the weekend. So we're not very happy with it, but we've not had the time to deal with it until we had this opportunity to redo it. So yeah, as you can see, there's our consumers, transformers, the assemblers, and then that's just our ingesters. So I've color coded those rings because you'll see where they fit in later on. So what were the issues? So as I've already mentioned, long deployment. So you can see there's over 200 Docker containers get deployed every single time. That wasn't out of design, and that's kind of become out of necessity. The idea was to deploy smaller changes more frequently. So if you go back here, let's say I've only changed how we transform a season. We've got new field and season, so I only want to deploy the season transformer. So that, unfortunately, doesn't happen anymore. Business requirements has basically said every time we have to do a deployment, we have to do a full refresh. If we want to do a full refresh, we basically end up just redeploying the whole thing, and it's a good half a day to a day wasted purely just for doing that. So what we wanted to do, and our design for what we wanted to do, has completely gone against what we end up having to do. So there's a lot of moving parts. So as I've already said, it's great fun when things go down. You have no idea what's going on. Because we're abusing Mongo, with the contention that we have with Mongo, you don't know what's going wrong. When things go wrong, you kind of like, it's kind of working. Its status says it's done, but I can't see it in Solar. Or, well, it says it's blocked, but I've got the object here. Why is it not working? Why is the agent not running? And it's all become just a general nightmare for us, and it's just been a real drain. But as a sense to show you what our abuse of Mongo was, going back here again, that airing, so the assembled airing Mongo collection up here, that is always getting written to all the time. And it's not a nice little thing where it's just, well, it gets a write and then it gets another write. Every single thing will try to write to a single document at the exact same time. So if you look at how many agents are running and how many are trying to write to that one thing, you get a lot of contention. And so it really, really slows down Mongo. Again, it's not a kick at Mongo. That is just purely just because we've abused how it should be working. So how can we solve these issues? So the long deployment, well, the obvious thing is just to reduce the number of Docker containers to deploy and to automate the deployment. We've already automated the deployment, but as I've already said, it still takes about half a day to make sure it's all working. To reduce it, well, we don't need that many transformers because we always deploy everything at the same time. So again, a lot of moving parts. Well, there's not much we can do about that because there are some business requirements that we have to process things in a certain way. But we've tried to simplify. We can try to simplify where possible. For example, removing statuses. So rather than trying to abuse Mongo, we'll actually process our data before we even touch Mongo. And then again, our complicated architecture. Again, there is a limitation on what a problem is, and you've got to deal with it in a certain way, but again, let's just try and simplify the issue. So how can Apache Storm help us with this? So with long deployment, we deploy everything in a topology, which is a single Docker container. Now, we have, I'll show you in the next slide, but we've got 3 topologies. So that's much nicer than having to deploy 200 Docker containers, and we even put those 3 topologies inside one Docker container. So from an actual physical time spent deploying it, that's brilliant. For moving parts, well, we're no longer trying to figure out what the state of something is. We've got Storm has given us this pipeline that we can just pass data along. We know where it is. We know what it should be doing. We know what has been done to it because it's got this fixed pipeline that it will always follow. And the complicated architecture, as you'll see in the next slide, it looks a lot simpler, but we haven't fully finished what we're doing yet. So it looks simpler, but I'll show you some caveats with that. But also, rather than going down to the very smallest detail where you have a process that will simply go from one object to another, or take this object from Mongo and store it onto another object in Mongo, we've kind of gone the opposite way, where we thought, well, actually, we've gone too fine-grained here, let's make it do more. So that gives us much better resource usage for our parallel processing. So rather than having a simple thing go from assets, transform function on-demand airing, we have this transformer that will take anything, and I can transform it to anything because I know what they map to. And again, as I've already said, you lose contention because you don't write that many times to Mongo. You only write the once to Mongo along the pipeline, but we read many times, or so theory will be. So here's the new diagram for what we're going to have. As you can see, it's clearly much bigger items, therefore less of them. So here, this is our consumers. So there's a lot more to them because, again, our bolts are doing small things, but we've only got 2, and they can deal with, and they'll be able to deal with any queue. You just replace the queue they're connecting to. So all they're doing there is we're using a JMS Spout, stick it onto a consumer, which will then dissect it, and then pass a Mongo bolt, which will store it into Mongo. And then we've also got this great little feature that we've got this raw message thing. So one issue we've had is we don't know what messages we received. Things were too complicated, too much data was coming in. We couldn't figure out the best way to deal with it. Fortunately, with Storm, we can just have it pass along the pipeline, and it will just split, and it will be happy with that. Of course, the downside is that if the raw message fails to store into the raw collection, it will send a fail, and the Spout will resend the message. So you do have to be able to deal with the same message being passed through the whole Spout, no matter which way it's forked, all the way to the end. So next bit here, that is our transformation. So that big long list that's taken up the whole screen is now done in just those 2 bolts there. Admittedly, it's called airing transform at the moment because we only have to deal with airing so far. When we do more, it will just pull in, it will just read from Mongo the data it needs. It won't do anything more. So when we get an airing, and the airing needs the series information, it will read from Mongo that series information if it's available. The next bolt is the suggestion transformer. So again, rather than having those 7 Mongo collections and a whole load of complication around on the top right-hand side of the screen before, we've now just got the 1 bolt. Again, much nicer, no need to try and maintain it. And then there we've got 2 bolts for our ingester. So all it does is it takes an object. I don't care what that object is. You're telling me to push it into Solar, I'll push it into Solar. All I need in the Solar wrapper is simply, do you want me to update or delete? And I'll deal with that. So again, as you can see, much nicer for us. There are some other things going on there. So, for example, we've got the DBQ spout. This is, unfortunately, it's kind of our current diagram. Things are likely to change soon, just because things are getting a bit more complicated. But in essence, this is all we need. You just need to add more logic into our bolts. So, I know it's probably been a bit of a rush, probably a lot going through. But are there any questions about this? Yes.
I'm curious, you talked about significantly reducing the number of Docker
Yeah.
Has that affected the throughput of your system, or are you finding that with Apache Storm you're getting much better performance anyway?
So to put that in context, so far again, because we're having issues trying to get data from the guys who we're connecting to, the data isn't all that great. It's only coming through slowly. But so far we've got only probably about an eighth of the data, but we've got one or two boxes compared to the I think 15 boxes we've currently got. And with that eighth of the data, it's still going through much quicker. So it's only taking like a few minutes for that data to go all the way through our Storm topology than it is for the full set of data to go through 15 boxes, which takes for about 3 or 4 hours. Admittedly, there's 8 times as much data, but it's not 8 as much time. It doesn't take 8 times as long. But again, it's slightly simplified. We've not got a full amount of data. We don't know how it's going to handle, because again, the old way of working was brilliant when we started, but when it started to come along with a lot more data, it starts to show problems. But so far, it's been fine.
Do you have functional testing proving that at all, or?
We haven't got non-functional on the endpoint, but the great thing is here, again, it's the same with the current architecture, is you've got back end and front end. So our only requirement at the moment for non-functional is purely on the front end. So it's where the red boxes hit solar. That is purely all that we've tested so far. There is going to be there is now the requirement that we do have to check, see how long it takes data to go through. In the old architecture, if I can make my way back to this, there is no way we can figure out how long something's taken to go through. It's far too complicated, far too many things going on, and we didn't design it to have it in. Of course, with the monitoring that we get, go back. Oh, there we go. You can see we've got a lot more fine-grained detail here, so we don't have to do anything. We've already got this ability to say, well, actually, do you know what? We're able to see this data going through really quickly. Here are points where it's slowing down. Do you know what? We don't want, because at the moment we've only got one of every bolt, but we can go, well, actually, the aim systems bolt is really, really just taking a hammering. So let's have 3 or 4 of them. Mongo can handle it, so why not? And of course, that will then hopefully go from red to green. Hopefully.
You said 1/8 of the data.
Yep.
How much data are you actually dealing with at the moment? Because if it's taking a few minutes to go through, is it like?
Well, again, the data is. We've got a couple of issues, because the main issue that we're getting is that the data we're expecting to get look like this. The data we're actually getting is completely different. So we're saying it's taken a few minutes, but we don't know whether it's just because we've completely screwed up our logic and how we're, because there's still, even here, you still see we are still storing to Mongo and we're still pulling out by Mongo. So if we put the wrong data in, you could be pulling out the object every single time. We don't know whether we're overdoing it or not. So, because every time we do it, something falls over, doesn't make it all the way through. You're like, why is that going on? Or so you see some going through, then all of a sudden something isn't making its way through. So again, I can only give you rough figures, but we're talking about 25,000 documents. It's not that many. So again, it's only, we're talking about 2 boxes with all of these running on it. So we've not done any optimizations at all. Ideally, we'd probably want to maybe break these topologies out for each one, maybe, if we want to do that, or even if we didn't, we would have much bigger boxes. At the moment, we don't have the infrastructure to actually deploy this to its proper environment. We're actually hijacking our current environments for this, and they're pretty underpowered. They're not even production environments. They're pretty underpowered. So there's a lot of, yeah, it kind of seems like it's okay, but is it really okay? We don't know. It's kind of very much hit and miss. Unfortunately, we've been working on it for 4 months, so we'll hopefully be a lot further than we are now. But as I said, just business changes, of course, different things happen. John?
JMS Spout reading from the VQ, is that a single point of failure? Spout. How would you add resilience into that?
So what happens? You have one. Sorry. So the question is the JMS Spout a single point of failure? The question would be yes, but no. Yes, we only have one. Nimbus makes sure we always have one. So if the spout dies, Nimbus goes, oh, hang on, I'm missing that spout. I'll bring it back up. I'll put a new one. So because it could be that you've only got one running, In which case, because you only have one running on, if you have, say, 5 boxes, you say, I only want one, it may only start one. That's all you need. But as soon as it dies, it go, oh, hang on, it died in that box. I'll better bring up on box B or whatever, and then it'll start. That will connect to it, and it'll start taking messages from there. But the key thing to remember, though, is that should your spout die for whatever reason, you need to make sure that whatever message it should have been processing, it can retrieve from its source. So in this case, with the VQ delta, for example, which is active MQ, we connect to it, but we don't acknowledge that we've consumed it until every single bolt has sent an acknowledgement back. Once that's sent an acknowledgement back, the spout then goes, I finished processing that, I acknowledge the queue, and the queue will then remove it. Yeah, so.
Can you give a practical example of the structure of the data that you get at the input, and then at the output when it gets to the transformation? What does it look like?
So, do you repeat it again? Let's go here. So what does our data actually look like pre-transformation and post-transformation? Yeah. Do you mean specifically to our situation or to Storm in general?
To your situation, what problem are you solving, and how Storm helps you to solve this problem?
Okay, so currently in our current architecture, you get an airing, an asset will come from our source, and that asset is just what we call in our world an airing. So it's an on-demand airing, and inside of that you have all the information you require and a lot of stuff that is just hollow, just not really useful. So this is all used by the new SkyQ box. Don't know if I can get an example. It's quite big. If you give me a second, I can see if I can. Oh, no, that's the wrong one. No. Where's my mouse? There it is. Let's see. Common. As you can see, it gets very complicated. I have no idea where consumer common is. Am I being blank? Can anyone see consumer common? Entity. This is a bit rubbish, isn't it? Alright, well, I'll just do open. Search. Right, well, that's a video, so we don't care about that one. Right, asset. So this is a Java object representation of our assets, the system that would receive. So it's a JSON, it's just a massive JSON payload which just has all of this information in. And then you've got things like it contains other objects such as catch-up. And catch-up just being things like it was on, say Game of Thrones was on Monday, so we've now got a catch-up. So we'll receive this as catch-up and it'll give you the information for a catch-up. So what we can do is from this asset is we can produce multiple different types of on-demand airings. So you've got things like catch-up, standard video on demand, OTT, which is for things like Sky Go, and the Sky Store, so things that you can buy. So they all come from an asset. So this is one thing we receive, and we can produce multiple things. But not only that, we get things such as unbound program. So this unbound program, which is actually type unbound metadata here, which is of type unbound data. So basically what these are is that, so we'll get multiple feeds. So one feed is what we call bound, and that is things from RBSA and TXTI. If you don't know what that is, basically you've got linear data and on-demand data. And with your linear data is stuff that you see in your EPG. Airings come through, and then but we want to enrich that information purely for ranking the airing, for improving our results and make them more searchable, is we then embed this program information that is on here, or season information or series information, onto the airing. Then that goes into Solar as one massive flat document, which we call an assembled document. So there's our assembled document with all those fields on.
That's a very flat structure.
Yes, we have to have a flat structure because that's how Solar works. You can't embed objects within it, and it's much more efficient to be able to query a single document and transform your document into a certain way that you want it than to have loads of objects and do loads of different queries.
On this case, we are doing different types of transformations so that you can extract valuable information about them.
Yeah. Yes, there's certain things that we use purely for ranking purposes. There's some stuff that we use for display purposes. So, for example, and there's some that we try with using certain fields, and then we try using other fields. So, for example, when we started off, we used the title and description from the Unbound program. We then found out they were actually pretty rubbish. So, rather than using that, we just used the airing ones. So they should be consistent, and they seem to be a little bit better. There are other fields, so for example, with Unbound, so with the program, series, and season information, because it's editorially changed, they have this thing called tags, and that's really useful for when we do sports matching. So for sports matching, what we're doing is we say, okay, the genre is sport, so we get this program, we go, oh, the genre is sport, subgenre is motorsport. We don't care about motorsport as a generic thing, we care about F1. So we then go through the tags to see, does it have any F1 tags in there? Go, okay, it does. Okay, so we now got this program. We know it's F1. We then get the teams and competitions that we've got stored for Formula 1, and then we then assemble those teams and competitions onto the program, assuming that's relevant, of course. So, you know, if the title was Russian Grand Prix, we'd get the Russian Grand Prix competition and let's put it on there. If it mentioned McLaren, we'll put the McLaren team on there. Likewise, do the same thing with football and rugby and a whole load of other sports.
So this is something like providing suggestions to customers to watch similar shows?
Yes. Well, no. So we are looking into that. There is another team called Recommendations, and they generally deal with that. But we've got a data scientist. They don't. So our data scientist is doing a lot of that work based on our data. So he's trawling through our data, using our data to see how we can improve the recommendations. So some of it is used for that. We don't have an API for that, so it's not externally accessible in that way, but the data is used for that, which is another thing that we're hoping with Storm, because we can just attach bolts to it. Hopefully it's be a bit nicer than having to create a whole load of processes that then have to be kind of added into our already horrible architecture. Yep.
Back to Docker. So you've got one Docker container for everything, or for each component of Storm?
Okay, so how do we use Docker to deploy our Storm cluster? So we have a Docker container for, so what we have is we create a base Storm Docker image. What that will do is pull down Storm and all the requirements to start Storm. So as I said before, you need to download Storm, unzip it, put it in the right location, da-da-da-da. What we then do is, that's our base Storm image. We then create a Nimbus Storm image. What it does is, based on the Storm image, we'll then just, all it does is start up Storm, uses the Storm script to start up as Nimbus. We can then use that image, deploy it multiple times. We've then got a cluster for Nimbus. Likewise, we do the same thing for Zookeeper. Again, just do Zookeeper and Storm UI and our Supervisor. So they are separate deployable. So we will have, for example, on our stage environment, which is the environment we've got at the moment, we've got 3 boxes, each with a Nimbus Docker image running. They each have a Zookeeper Docker image running, and each have a Supervisor Docker image running. Because they're all Dockerized, they think they're on different boxes, but they're actually on the same box. So we do have some kind of resiliency. Although the Supervisor, only really deploying to 2 supervisors, but yeah. Okay. Anything else?
Since one of your requirements was to deploy active-active,
yep.
Are you achieving that today?
Yes, we are. That was so. One of the reasons why we went down the route of using Mongo as a central kind of repository of holding state for everything is because we can have that clustered across both Haml and Slough and have an arbiter up in Onyx. And it's been resilient. It's not fallen over. It does work, but it's just a bit cumbersome.
So where do you deploy your supervisors? Do you have one data center?
So for stage, which is the only environment we've got, is only in one data center at the moment. Because again, we're limited on boxes. We don't have the place to store it, but we know exactly how we'd do it. We're ready to, like I said, with Zookeeper, already know how it's going to work. Nimbus, again, we've not upgraded to 1.0, so we've only got the one. We've got multiple Nimbuses deployed, but only one's actually running. Does that make sense? Because we haven't upgraded to one yet. Likewise, Supervisor, we've got deployed on a couple boxes, and they are working. So our assumption, we do have the assumption that it's going to work. We just chuck it, because at the moment it's in Hemel. Chuck it in Slough, it's then going to work, but it's not been put into practice. We do.
A topology that crosses data centers.
No, you have a topology. Your topology is just a single thing.
Mongo that's replicated.
So we're not currently using Storm, but in our current one with Mongo here, behind. There you go. So you can see Q will be the Q yellow cylinder. That's a Mongo instance. That will be, I think, that kind of keeps the queues, the topologies connected.
So if you lose your data link between two data centers,
yeah.
What's stopping you from Jupyter Spout, those data centers then going off?
As I said, we haven't tried all this, so a lot of this will be completely new to us. The idea is that that shouldn't happen because Nimbus should be able to deal with it, but it's just not something we've tried. We've not tried taking. Again, we're still at a point where we only have one Nimbus running because we're still using pre-1 release. So it's not even clustered. So that scenario doesn't make a difference because either one data center is going to work or it isn't going to work at the moment. Following that scenario because we only have one Nimbus running. But yeah, should we have multiple? I don't know how that will work. I'd like to think that they've thought about that. Oh, yeah.
Did you look into any other technology for Untitled Storm?
Did we look into any other technologies? Yes, we tried doing it ourselves, and after about a month realised this is really cool, but I don't want to use it. Then we had a guy join us who's from Yahoo, so he used Storm before. We were under tight time constraints by then. We did want to try some others, but it kind of became a business decision. Either you go with what you've been working on, or you do Storm and just fail fast. So we decided to go with Storm. We did have a quick look at other things such as Apache Spark, but they're batch processing, and we don't want batch processing. We want to be able to send single documents through. You can make Spark work like that, but it's why would you? If you're going to use the correct tool, use the correct tool. Don't just hack something else to make it seem like it works. Was our approach. Again, we've not tested this in anger, so we don't know. Should 6 months' time, it's been running production for a while. The whole thing, is it really working? Like we didn't find out with our previous one, but hopefully it's in that. It's shown signs of being much better. We're much happier developing with this.
What's the code base look like for this? Is it one Git repo, or is it many Git repos?
At the moment, it's one Git repo for the topology. So for this, all the yellow boxes is one Git repo. That's not how it's going to end up being. It's just we don't want to have to faff around right now with creating libraries and blend them all together because we're under the time constraint. What we're going to do is we're going to have each different thing that we can break down each different thing as different libraries, is the idea. So for example, we'll have transformers as one jar. We'll have the Delta consumer as another one, the refresh as another one, that kind of thing. But you still need that central project that will just pull in all these jars. So you do need to have one jar that has everything.
Yeah, I don't think it's going to be a problem longer term though if you've got to redeploy everything.
In what way?
Well, if it's all in this one repo, it's part of one deployment, you've got to restart everything.
We do that anyway right now, but just loads of Docker containers, so it makes no difference.
That's the problem as this gets bigger.
Well, in terms of the maintenance, as I said, each different thing's broken down into its own components, and then all the central repo, all that will contain is just our end-to-end tests, so it can all run in memory and run everything together and then deploy it. It should just be an automated job where Jenkins will go, okay, I've seen there's been a change in I know transformers, and you've pushed it and it's gone to Artifactory, I'll run the central repository with the latest set of code. And then you've got a Docker container that you're going to deploy.
Yeah, I guess I'm just comparing it to microservices. It's like this big distributed Apache camel system.
Yeah, I guess the point is, though, from our point of view, I see where you're coming from, but from our point of view, we've just done microservices and we hate it. So maybe come, as I said, maybe come down 6 months down the line, we'll change what we're doing, how we're doing it slightly differently. We might have each topology might be its own separate thing. We might break down topology into even smaller things, because right now we're using Mongo to connect our topologies together. That's not what we're going to do in the future. We're going to do things differently because we know that there's already caveats with using Mongo in that way. So eventually we'll probably end up using something like Kafka, or create our own solution around Mongo to be able to deal with only allowing certain data out. So for example, for our issue that we know we're going to have is a delta message has 2 lists inside of its wrapped object. One of those lists is update entities and one is deletes. We've been told that an update and a delete cannot appear in the same message. So if you've got Game of Thrones Season 1, Episode 1, and the ID is 1, you won't get an update and a delete with ID of 1 at the same message. But you can get message 1 has update, ID 1. Then the second message has delete, ID 1. Now, the delete and the update pipelines are completely different speeds. So you can have the situation where a delete happens before an update happens, in which case they've completely screwed up. So we're going to have a wrapper around our whatever we have in between. We need to make sure that only one instance of this message with this ID can be processed at a time. We haven't finalized that design yet. So how that's going to look, I don't know. But that's just purely because we want to be able to have, say, like 5 airings going for this all at the same time, or I don't care if, I don't want to block my seasons because I've got an airing going through. Because if we're doing that, then there are other ways that we can deal with it. So we haven't decided that. But I see your point. There is the issue where you are just deploying one thing at a time. But as I said earlier, our kind of business requirement at the moment has basically ended up being every time you do a deployment, you have to do a full refresh. In which case, we're pretty much deploying everything anyway. So doing microservices is just a pain. Yeah.
How much data do you have, and how quickly does it come? Is it just VQ or something additional?
How much data do we have now in terms of for the Storm stuff? Or
how much are you planning to process? Is that data or is it something?
Well, this is why we haven't got very far, because the correct answer is we don't know. We don't know what we're supposed to be consuming. We don't know what we're producing. Every couple of weeks, our requirements are changing. Originally, we were supposed to be taking a VQ, which is on demand. No, sorry, VQ is a new structure that we've never seen before, which is why it's not really working. There's the LQ, which is linear. We've got DQ, which is descriptive. TQ, which I think is something else, I can't remember. SQ is sports, and you've got all these different data sets. Because, for example, at the moment, we're scraping Sky Sports API for sports data. We do that once a day, and it doesn't really change. It's not that big. But when we go to consuming a sports queue, what's going to change? We're going to have a lot more sports. How frequently is it going to be updated? We just generally don't know. And for this Storm stuff, our only requirement is VQ, because a VQ object, unlike the asset which I just showed you, the VQ object has everything already as a flat document. So it's like having the assembled document pass through to us, and that's a much bigger object than anything we've had to deal with before. But to give you a rough estimate of what we've got now, when we're consuming bound and unbound, it's about 400,000 airings, I think, something like that, from bound, and then about 2 to 3 million metadata objects, of which about only like 500,000 actually have anything that we need. But yeah, as I said, with all this stuff we don't know what's going to happen. Because, for example, right now on the APIs, it's just simple suggestion free text search, which is just, I give you some string, you give me a UID, so just a unique identifier, so we can then call elsewhere. Come 6 months down the line, I'll go back to this original idea, which is, I give you a UID, and you give me a whole load of information about it. I give you some text, you give me a whole load of information about it. That may be the case later on, which is what it is now for our current system. Anything else? Thank you very much.
Thanks, Ben, for a very good talk. It's very interesting. And on the way on to please grab some snacks. I don't have to carry that all the way back.